The average image is high accuracy and it's all very versatile in multiple domains. So this will be also the objectives for our project, which is to build a question answering system for historical data using RAG and LLM. And we will try to implement some methods to resolve some of the existing problems directly from the historical data. And finally, we try to propose some metrics for the final answer generation evaluation without the ground truth and have some discussion on it. This is the base model, which contains two main parts, retrieval and generation, each of which contains smaller components, which will be in more details in the next sessions where I talk about the system components. So the first module I want to talk about is information retrieval, where the input is the query and the output is a retrieved chunk of text. First of all, the corpus of text will be embedded using an embedding model. In this case, it's E5 multilingual, and passes an index into a database, a grammar database. In the runtime, the query will be passing through the same process of embedded and retrieve and go into the database to retrieve some relevant chunk of text using a function here is maximal relevance. So to make the retrieval method more robust to the retrieval to the interval data, and we also try to fine-tuning the models. So there are two approaches for this. First is to directly fine-tune it on the target domain, and we are using here GPL, which is a method that helps to fine-tune the model without any ground truth, unsupervised way. The second approach is firstly use an adaptive pre-training. In this case, a TSDAE, which is an improvised version of mass language model on pre-training, and then also fine-tune it on the target domain. Next, before the retrieval method, we also have some module to increase the performance of the system, which is of retrieval. The first is query routing. This is to direct the behavior of the system in some necessary ways depends on the input, which is the query. So it will search for if the query is have the answers in the database or not. If not, then we will run directly to the web search, or if no, then we move on to the information retrieval path as usual. But of course, in the project, we will focus solely on the information retrieval path. The next pre-retrieval module we'll be using is query expansion, where you can see that there are two methods. First is to generate the queries directly from the original query, givens to give the system more aspects around the original one. And the second approach is to directly add some relevant terms to the original query by asking RM some important questions. This will be two approach, and we will see it in the earlier part. The post-retrieval, which is a part where we try to refine the list of the retrieval documents, we are using rewrapping module. The upper path is the normal rewrapping, where we try to put both the passage and the query through a coherent rewrapper. This is a more sophisticated than E5, which gives more accurate score. The bottom path is our proposal of injecting name entity recognitions to add more information to the system. First, we try to extract the name entity, then we use TF-IDF to vectorize all the extracted information. We will finally calculate the name entity recognition score. The final output will be the weighted sum of these two scores. So after retrieving, we will move on to the answer generation part, where the input is the query and the received passage, and the output is the final answers. And you can see here we use Llama 3 instruct versions, which is here you can use the prompt to guide the model to give the desired output. And after giving the answer also needs to go through two verification steps of self-RAG, which is to ensure the quality of the answers. By first check if the answers based on a retrieved document or not. If they are hallucination, then we write back to the answer generation. And if not, then we once again verify if the answers will answer the questions or not, and then we retrieve more from the web search and finally the answer. So this is the whole pipeline of the complete system. We first query routing to see if we need to go to web search or information retrieval. Then after we got the retrieved information, we write to the answer generations before passing through verification steps and then deliver the answers to the users. So this is the timeline, and we run now for the evaluation part. So first, we want to calculate some quantitative evaluations on the summative score. The evaluation we are using is miracle data, which is a evaluation benchmark, information retrieval benchmark data, and we are using 3 languages in total: French, Finnish, and the English will be used as the baseline for the answer generation module. And you can see that this sums the information from each of the language. The number of passage is the main thing we will be working on, which is the chunk of text. The number of articles is a higher level of passage. The number of queries is some sample query existed in each language, and the number of judgment is whether the query is relevant to the passage or not in the binary score 0 or 1. And the setup for the experiment is to take advantage of both the chunking and the title metadata has already given from the dataset to create the titles database and the corpus database. The retrieval model will be used in E5 small version, and the query expansion is multi-query. The ranking method here we only use coherent rank with no injection method, and the final is the llama 3, which we set the temperature to be 0.3 to make the answer more flexible. And this is the result. And you can see that using E5 clearly improved the model performance compared to E25, which is the base model using in the original paper of miracle data. And by incorporating it with some pre-retrieval and post-retrieval methods, it also improved the model by a large distance. Then for the answer generation evaluations, we try to propose some of the methods to evaluate the final answers based on some of the retrieved documents. And we're using 4 main score here: AS score, the birth score, the score size similarity, and the quality index. Notice that the quality index will be a distance-based metric, so it will have the opposite trend from the others. And this is the result. And you can see that the Finnish data are having some of the most inconsistency results out of all of them, which can be inferred that the llama 3 model are incapable of generating some answer or deal with some unspoken language such as Finnish, while English and French are having more consistency across all the metrics. We also try to calculate some of the correlation between these its 4 scores, and you see that the birth score and the co-sensitivity are having much higher correlations, which can be due to the fact that they both simply use embedding models, dense embedding models for the usage, while the quality index also having some very promising results, which show some very expected trend of negative trends compared to others. The Finnish also show some consistency here due to the poor performance I have talked about. And now we move on to qualitative evaluations, where we try to evaluate the system on directly our main target data, news data, which is a multilingual data set containing historical newspapers from 3 languages: French, Finnish, and German. And this is a sample of how the news data set. So for the setup, we will divide the passage by the paragraph tag and the title heading. The title will be the first heading tag. The retrieval model will be the E5 large version, enhanced by some Pythonic approach. And the query expansion will compare both multi-query and CSQE in this case. For the ranking, we try to inject information, namely the recognition informations, and llama 3 will remain the same. And this is the results for retrieval results. I have it translated into English for better. So you can see that with the use of ETL and USTH as a Pythonic approach, the result is giving more reasonable answers now. And it showed that the retrieval model can now be more robust to historical data by using some Pythonic approach. So the GPL seems to be slightly better in this case, but need more experiments to test really which one is the better. For the query expansion results, the first is the multi-query generated query, and you can see that some of the query in this case is having some very specific intent of temporal information, such as in query 2, which can be causing some hallucinations in the large language model afterwards, which is not necessarily in a historical data. So with the CSQE, which is a more constrained version, by adding some terms directly to the original query, the results still show that the system is working well by it's still adding some more relevant aspects of the data. For the rewriting results, by adding, so in this case, we deliberately damage the query by adding some damage into the name entity of the query, which can be the OCR errors or the name entity changing in the real data. And you can see that twice doing that, the query score is relatively low compared to the original score of the E5 encoder. So by rejecting a more constant score of name entity recognitions, you can somehow boost the score higher. And this refers to a experiment in the future works where you can put more information into the pipeline. And here's some of the final results for our system. You can see that it's working pretty well on this data, on some of these samples. So for the conclusions, the application is that the system has provided a very consistency in information retrieval modules across multiple languages. And with some approach I have mentioned, is now more robust to the OCR errors. And some metrics I propose also show very high correlations together. The advantage, however, is that the answer generation module fails at a less spoken language, such as Finnish, and the metric is very restricted to ideal conditions, where it's only the aggregation of answers for now. So in the future work, we try to improve the LM models using reinforcement learning for human feedback, or try to develop the metrics to be more comprehensive in generation tasks. And we can also try with other unique embedding methods, such as LM2Vec, or integrate more information into the system, like image or table. So that's it for my presentations.
Yeah, great work. Yeah.
Okay, so the first question is about your dataset evaluation. I don't know, I don't understand why with the Miracle dataset you consider quantitative evaluation, but for USTH you do the qualitative evaluation, and why not both?
I mean, for the Miracle data, it's a benchmark data, so they have the data set. For the USTH data, I mean, for now, they don't have any historical data for the RAG approach evaluations. So we can't really evaluate any of those in metrics. We have
okay, so I can understand that you don't have a standard your data set for USTH, but why don't you evaluate Miracle with qualitative method?
Actually, I have made some, but I don't think it's main target, so I don't really push it. I mean, I have made some of the.
Because
so
intuitively, you think that you need to have something to compare between the your results when you evaluate one data set and another data set. A second question, in fact, you mentioned at the beginning about the historical data set with errors from OCR, things like that. It's kind of like you say that you have a problem to resolve.
Two challenges,
Yeah.
OCR problem and
In comparing to other data sets.
Yeah.
But at the end, I don't see
I mean, there exists.
anything.
Yes.
But
Could you give us some concrete example about OCR error cause difficulty in answering?
Some of the beginning slide, I remember.
yeah, but even that you have nothing to show that it's the
Okay, you state
challenge.
that.
challenge.
So this is the French versions, and I mean, so here some of the so I could show it in more detail when we have time, but some of the tables or some of the image is very damaged, especially with some of the very short headings. They are misleading, classified.
I think it's understandable. Yeah, of course.
We do agree. But
Yeah.
please give us and analyze very concrete example about, okay,
What does it change regarding your methods?
I mean,
Your
you can see here.
methodology, I mean, about your methodology, what does it change your
Yeah.
method to
Yeah,
have a
very
solution? Because you will use the same solution
No.
for this data set and another data set.
I have been said that I have added a name attributions. So the fact that name attributions, I have mentioned that they could be changing throughout the time or from the CRRs. So by adding it adds more constant informations to the system by always basically it will add more injecting a more constant informations despite it can be changing because it's always a named entity. And I have shown it here from the quantitative evaluations. So you can show that with the name theoretical score, even when the name is in a wrong case, it still somehow boosts the final score of the cohere because we are using a very constant score name entity.
What I mean is, when you have some challenges for your data set, maybe you propose something new that apply for this data set, but not for other data sets. So
I thought this is
Yeah, let me come back to the statement of your research about the challenges for historical documents. Yeah, challenges. Yeah, OCR errors. Different temporal information. There are two challenges.
Yes.
You mentioned two challenges.
Yes.
Now you propose something to solve the challenges.
Yes.
Right. So what? Yeah. The concrete example to solve that. Yeah. Due to the OCR error, other method fail, and your proposal work well, right?
I mean, I tried deliberate it, but I don't.
Sure. Yeah. You know her question.
Yes. Yes.
You raise two questions, two challenges by yourself,
Yeah.
and you propose solution to solve those two challenges by yourself, but you don't show us the result of your solution. For example, without your solution, yeah, for example, this case failed, and with your solution, it overcomes the difficulty of OCR error.
I mean, I get it, and
show and analyze very concretely about that.
I mean, this could be.
you haven't done that, the analysis. So the written analysis to show that.
Now you
No,
highlight
because-
you highlight the OCR error.
Not really the OCR error as I highlighted is this, where I deliberately damage the query from the users, because I mean that the previous has spot out that there's a name changing entities in the temporal information, and so I deliberately damage it by removing some of the words roughly. So I mean that the system can be more robust to this name entity changing even in the data. So that's some of the. So I mean the coherent score here.
It's been that you make the OCR error by yourself artificially.
Yeah.
So you should analyze more clearly, because you modify the original text by changing the text, for example, to simulate the OCR error. But the way of making the OCR error should be present. For example, in this case, you delete some or you change some characters, but the OCR error is quite different. Right? You can recognize very similar characters or similar words. They may cause error for OCR. Right? If you generate the OCR error by yourself, you should present it. If not, we don't know.
Yeah, because you propose the method.
You propose by yourself some challenges, right? Propose some solution, and we need the proof. Yeah, right? Okay. Now in your methodology, you use both large language model together with the knowledge base, right? So show us some knowledge base.
The knowledge base is the embedding the Chroma database.
It's called the knowledge base.
Yeah, is the knowledge base is basically where you having a embedding database or graph.
Yes.
I mean, the definition is
So
flexible.
right, large language model and knowledge base. Now
Yeah.
show us one slide about your knowledge base. Where is your knowledge base and what it is?
Here is the Chroma database, where
Which one is knowledge base?
here, where is the embedding database for
A knowledge base means the knowledge and the inference mechanism, right?
I mean,
So you should make it very clearly about what is knowledge base.
Yeah.
Because in machine learning, in AI, we understand that okay, knowledge base is a set of statements and inference mechanisms. So if you want to talk about the knowledge base, you should show us two basic components of a knowledge base. Right? You could not draw a graph and you say that okay, this is knowledge base. We need very concrete. For example, knowledge base is some rules, for example, and mechanisms of the inference. Here is the mechanism of inference, for example.
I mean, in the report I have already shown a very, I think, draw a very detailed example of Chroma database. And
Yeah, but I think that is important, and the important content should be on the slide. Now, could you show us some concrete knowledge base? Because it's a knowledge base it's coming back to the knowledge base and the large language model, the limitation of the knowledge base. Beginning, very beginning slide. Yeah, this one. Limited in user cases. Limited, yes. We know that knowledge base, yes, limited in user cases. Now, how many user cases here are there in your?
I mean, it means that it is very depends on the specific task without the large.
And I'm asking about your experiment. That's very concrete.
I mean, there is the background, so this the statements from the previous works.
Okay, we know that, but because you combine both, right? Okay, large language model, we know that, you use some models, some feature models, some mechanisms of generation, and you wanted to overcome the limitation of the two methods by combining them together, right? So, firstly, I don't know what is exactly, concretely, your knowledge base. The second one is because knowledge base depends on the domain, and domain depends on the resource. Of course, in some cases you have very limited, or small knowledge base. Some other resource cluster domain, for example, you have a much larger knowledge base, and much larger knowledge base, provide more, complete answer for your problem.
I think that you should explain better if you put all the statement in the text.
It means that your problem statement
Information retrieval, you see?
and methodology and result should come together logically.
Because you say something very, very general, why we talk about information retrieval, you have a text, so your corpus, which constitutes the knowledge after. So you should precise everything like that, because not everyone work in the same domain. So when you present something here, you should be much more
Okay.
Okay,
specific.
Mr. Bien. No comments?
Yes.
Okay, now my next
Next
question. One more.
Comments about the thesis, because we need something to improve too. the related works, you have just one page, so you should move that in the background section, because you talk about breath, and it's really nothing to put a chapter, just one page like that. And also you should invest more for your formatting, because it's very unclear to read your section, subsection, difficult to follow your text.
Okay, thank you. Now my last question, what's your plan after graduation?
Planning to probably apply for the master's.
Apply already?
Not really.
No. It means that after graduation you have nothing.
Yeah, because I have just contract.
No job offer, no scholarship.
I mean, the master for the USTH only opened in the August, so for now I can't really apply.
Yeah, but we don't. Yeah, still not sure about that. Right?
Yeah.
Yeah, we should think about that. Yeah. The future career. Yeah, why do you need to go to the master?
Because in this field, I believe that usually the master is open up.
Okay, so what happened after the master? What job
Then-
after master?
It depends.
Yeah, because if you want to go to master, it should be, for example, you go for the academic field. Because for some company they don't need a master people, only people. Because it require more and higher salary, for example. So many companies do not prefer the master only degree people. So please consider about that. If you want to go to the university research institution or to PhD course, for example, you should think about master. But if you want to work for some company, university is not 3 years. Okay, think about that. Yeah, every people should be better answering for the question. What's your plan? Yeah, thank you.